Hello and welcome to another LeetCode problem. Today we're going to be doing the problem of the day for June 20th, K radius subarray averages. And so you're given a zero index array nums of integers and integer k. I'm just going to explain what they mean without reading all this because this can definitely be a little bit confusing. But pretty much you're given an integer k, and let me draw out this example. So let's say we have this array and it has 9 elements. Yeah, so 1, 2, 3, 4, 5, 6. 2 more. Okay, and so you have these elements. And yeah, I'm going to try to explain it in an easier way to make it understandable. So pretty much we have an output array that needs to match this starting array. And so here k equals 3. So we can have it just right here. And then the default value for anything that you can't have is going to be -1. So let me draw that. So just -1, -1, -1, -1. Okay. And so they're saying that k is the radius of points. And so for every point, we need to figure out what's the average of the subarray with that center. And so for something to have a radius of 3, that means that we need to be able to go 3 to each side. So for example, if we're at this point, we can't go 3 to the left, so we don't have to do anything here. At this point, we don't have to do anything here. At this point, we can't go 3. So it's 3 including, like, it's 3 past the point. So even though we can go 3, it needs to be 3 past the point. So for example, here, we're at this point 9. We can go 3 here and 3 here. So this is a valid location. And so now basically what they're saying is just give me the average of this whole thing and then store that at this index over here. And so it's pretty straightforward. All we're going to be doing is we're going to be traversing for every single possible center. We are going to take the average and then we're just going to store it here and then we're going to keep going. And so we need to think of ways to optimize this because, for example, let's just say we took every point where there was a valid center, right? Like we just went through these points and we said, okay, we can go left, we can go right. Now give me the average. What's going to be the time complexity here? So that's going to be pretty big because every time we need to compute 2k numbers, right? And we need to get the average of that. And then there could be at most, like, let's say the length of this array is n. There could be n different things we need to compute for. So that's going to be something like n times k. And so that's going to be a quadratic complexity. So we need to figure out how we can make this cleaner. So I'm going to go over how we can make this cleaner, but let's just go to this example real quick to show you. Now, hopefully you know what it means. So yeah, they're saying like at this point 9, we do have a valid center. At this point 1, we have a valid center. At point 8, we have a valid center. And everything else, we don't have a valid center. So only for these 3 points do we have an average. So at 9, it's the average of all these numbers in red. At 1, it's all the average of the numbers in blue. And at green, it's that. And so for example 2, they're saying here's our nums, or k is 0. So now our radius is 0. So we don't have to be able to go, like we have to be able to go 0 points from the point we're at. And so that's just, then we only have one number here. And so that's just going to be this, right? Like they're saying we have some number here. And then from this point, we have to be able to go 0 points. So the output is just going to be x. Okay. And so let's actually look at the third one. So the third one, they're saying we have 1 point again, but the radius is huge. So we can never actually, have something long enough there. So it's -1. Okay, so let's go over what we would do here and how we can do this efficiently with k equals 3. So first thing, like I said, is we're going to have this result array. We're going to initialize everything to -1. Now, we don't want to do the n squared approach, right? We definitely don't want to do the n squared approach, so we want to try to have a big O of n solution. So this is going to be a sliding window, and I'm going to show you some tricks I learned to make the sliding window look a little bit cleaner, kind of like the default template for a sliding window, how you'd want to use it. And then you really want to be consistent in how you use your default template for most of these like algorithms, and then you can just make a few changes for the problem you need, and that way you're going to be able to write code that's pretty efficient, and you can write it quickly, and it's going to be error-free. Because if you make different algorithms, like you want to have a template for each algorithm, and then you want to be able to figure out what small changes you can make, because that's going to be the easiest way to make sure your code is actually working and it's error-free. And I'd advise the same thing for other algorithms like binary search. I've seen binary search, where people have like They have like L is less than or equal to right. Sometimes they have L is less than right. Sometimes they have L, and just like you can pretty much do almost all the algorithms with just one format. With just this right here for binary search, for example. And the same thing for sliding window. You can pretty much do all the algorithms with just a default template. And so I'm going to show how that's going to work. Okay, so what we're actually going to do for the sliding window is it's going to be pretty straightforward. So we're going to have a total variable. I'm going to call that t, which is just the total of our numbers in the sliding window. And they usually want something like that depending on what they ask you for the sliding window, where it be a total, where it be like, you know, some letter counting. You can figure out what you need there. But so for every sliding window, we're going to have a left and a right. So we're going to do that. They're going to both start at 0 for pretty much every sliding window. You can start at the right at like a little bit more efficient place. Like if you know that your thing needs to be length 7, for example, you can actually start at index 6, and then you're guaranteed to start with an actual sliding window that's complete. But you can just do this and then, you know, make it bigger and then have the check. And time-wise, it's going to be the same exact time pretty much. So we have a left and a right, and then we also want to have a window size in this case. So I'm just going to call that size. And so our window size, if you think about it, so we have a k, and our window, remember, needs to have an element, and then it needs to be able to go k elements to the left and k elements to the right. So our total is like we have the middle, we have the left, we have the right. So our total number of elements here is actually going to be 2k plus 1. Okay. And now we're pretty much, so for every sliding window, it's kind of similar. You're just traversing, and you're traversing one element at a time until your right is out of bounds. And then you just need to check, is my window valid? So what we're going to do is we're going to, like, let's say our left and our right is going to start here, right? So both the left and the right are going to start here. I'm going to draw that. I'm going to draw the totals. And so first thing we do is every time we get to a new element, we add it to the total, right? So let's just put the total over here. Let's delete it from here. So we go through the first element. Okay, we add it to the total. We check, is our window of proper size? And by that, so the window size for a sliding window is always going to be right minus left plus 1. So if you think about it, like if these are both 0, then the window size here would be 0 minus 0 plus 1. So you're saying, is right minus left plus 1 equal to our size? And that's kind of like, for this problem, that's what we need to do to check that our window is actually a window that meets our criteria with a k that's at least 3. Okay, or this will work for any k because we have a k, but yeah. So we check, does our window meet our criteria? Well, here the right, so the size here is always going to be 7, right? With a k equals 3. So our size is 1, so it clearly does not. So if it doesn't, we just keep going. Okay, so we're going to move our right over here. We are going to use this element. So now our new total is 11. Okay, what's our window size? Our window size is 2. No good. Okay, we'll move over here. We add 3. So our total is 14. Okay, now our window size is 3. No good. Okay, we move again. We use this element. Our total is 23. And we are at index, so I'm just going to draw the indices down here, just to make it clear. 3, 4, 5, 6, 7, 8. Okay, so here we are index 3, which means right minus left plus 1 is going to be 4. So we have 4. Window is still too small, so we keep going. Okay, we use this 1. Okay, our total now is 24. What's our window size here? So we are index 4, so our window size 5. Too small. Keep going. Okay, right, so over here, our total now is 32. So let's just read this. So we're trying to get 7. Remember, we're trying to see if it equals 7. Now we are at 6 because 5 minus 0 plus 1 is 6. Too small. Let's keep going. And okay. Let me just make sure here. 1, 2, 3, 4, 5, 6. Yeah. Okay, perfect. So our window is still too small, so we keep going. Okay, we are here. And I think we did add this 8. Yeah, we did. So now we add the 5, so we are at 37. Okay, so now we finally have a window that's big enough because our right is 6, so now we are actually at 7. Okay, so we do have a valid window here, right, where we used all of these elements. But the question is, where in our results array do we need to actually store the result? And if you actually look at this picture, like once we do have a valid window, we're actually at this index here, we're at 6. However, we need to store in the middle of the window. We're not storing at 6, we're storing in the middle. And so where we're storing for this, if you think about it, like let's say we have a left and a right, and this is k, so this is 0, this is 6, we need to store in the middle. And so the middle here is actually going to be left plus k. So that's the index we're going to be storing if our window is valid, which in which case it is. Our window is 7 length long, and that's what we want. Okay? And so then that means we need to be storing at L plus K. K is 3, L is 0, so we need to be storing at 3, whatever this average is, and this average happens to be, let's see here. Well, actually, we can calculate it, right, because we have a total. So we have a 37, and how many elements do we have? We have 1, 2, 3, 4, 5, 6, 7. So the way we get the average that's going to be efficient is we have a total, and then we're going to take the average over here. We're just going to calculate the average on the fly, because then we can just keep changing the total, and we just keep calculating the average on the fly. So the average, we want the lower bound integer average, and so we have 37, and we have 7 elements. So we're actually going to do an integer divide here, which is going to do a lower bound divide. So it's actually going to be 5. It's going to be 5 point something, but we get rid of the decimal, so it's going to be 5. So then we are going to store 5 at index 3. So we're going to change this to a 5. Okay. Now, what we need to do is, now that our sliding window is good, remember we're gonna go to the next right. But now we actually need to move our left. From this picture, you can see how you have the sliding window here. You see, once the sliding window is actually big enough, you need to start moving the left now, because we need to make sure our window stays the same size. So we're going to keep moving the right, and we're going to keep moving the left. So now what we actually need to do is we need to take our left and we need to move it over here, but we also need to decrement whatever the left value was, because that left is no longer in the total. So that value was a 7. Probably shouldn't have crossed all these out. It makes it a little harder to see, but we're actually going to take this 7 and subtract it from our total. And so now our total is going to be 30. So let's just make it here, and then we keep going, right? So our right now is going to go over here. We're going to add 2. So plus 2, 30 plus 2 is going to be 32. Okay. Now, our window is always going to be in size now, except for when we start going out of bounds, and I'll show you what that looks like. Actually, no, we're never going to go out of bounds, right? As soon as we go out of bounds, we're done with the algorithm. So we're never going to like go out of bounds. Like this right will come over here, and then it will go out of bounds, but I'll show you. Anyway, so our window is going to be long enough again. So now our left value here is 1. And so what's the middle? So our window here is actually this. And so the middle is, remember, left plus k, so it's going to be left plus 3. So for index 1, we're going to go to index 4. And now what's the new average? So the average now is 32 over 7, which is 4. Hopefully I did these numbers right, but maybe I miscalculated something, but this is like, you still see how the algorithm works. So that's a 4. And now remember, we are storing at this index over here. And so you're always going to be storing at like the next index in the result array, because you're moving your sliding window 1. So it's going to store over here. But yeah, it's going to store L plus K, which would be 1 plus 3, which would be at index 4. And then we would be storing a 4 here. Okay, now same thing. We need to move our left again. So our left was here. And so we need to move it one more time. That means we need to get rid of the element that was in the left. So we had a 4, so we're going to get rid of it. So 28 here. Now finally we go to the last right. So our left is over here. Let's get rid of all this. Get rid of all this. So now our window is actually this window here. Okay, definitely you could have drawn a little bit cleaner, but so we need to add a 6. So we're going to add a 6, 34. Our window is still big enough. Now we take the average, 34 over 7. It's going to be 4 because lower bound again. So now we put a 4 over here. And now we subtract left from the total. We move it again. So our left value is this value here. So we're going to subtract the 3. Now our total is going to be 31. Now we are going to be done, because we are going to move this left again, but now our right is out of bounds, and that's our condition. So we're saying while right is in bounds. So now that our right is out of bounds, we're done. And if we actually compare this to this, hopefully we did that right. So it is 544 as in there. So that's going to be the algorithm. We are going to construct the sliding window. We're going to be moving it. and we're just going to keep checking, is our window size big enough to meet our requirements for this radius thing? And as soon as you can see in the picture, as soon as the right side of the sliding window is out of bounds, we're just done. Because you can realize that as soon as the right side of the sliding window is out of bounds, we're never gonna like have a valid answer. We're gonna be at some index that we're never gonna be able to go right far enough here, right? So like we would want to be storing in this place right here, but we're never gonna be able to go 3. And so that's a sliding window. I'm gonna show you the template first, and then I'm gonna actually code up the code. So the template for the sliding window is you pretty much say like while, and this, I think this is a little bit cleaner as well. So what you want to use, you don't actually need to even initialize a right, assuming you're starting with the, assuming your right pointer is going to go all the way to the end, and we can just start it at a 0 like I suggested. So you just have a left and 0 and a right equals 0. So you would have something like left equals 0, and then you could say like for, in this case we do want the actual value, so we're going to use an enumerate, but we'd want to have something like for right value in enumerate nums here, right? And so this is like the template for the sliding window. You can either use an enumerate or you can use a for range loop, and you can actually use your right as the index already if for most sliding windows. Alternatively, you could have a left equals 0, you could have a right equals 0, and you could manually increment them. You could manually increment them in the while loop, and then you could just say like, is my right in bounds? But that's the template for a sliding window, and then in here you would just say like check that my window satisfies some condition, and then usually if it does satisfy some condition, you have to record some stuff and then check to make sure that I have to move the left pointer, so like the left side of the window. So that's going to be the template for the sliding window. You're always going to be moving the right, but you need to check if you're moving the left. And then if you're satisfying some condition, then you probably want to have some like outputs that you're doing. Okay, so in our case, for our problem specifically, remember we need a window size that we're going to be checking for. And so that's going to be 2k plus 1, right? From this picture, if k is 3, we need to be able to go left k times, right k times, and have a middle element. So that's 2k plus 1. We also need a total. We're going to have a 0. And so now we are going to start going through our code here and fill out these sections. So first we do total plus equals the value. Now we want to check if our window satisfies the condition. So that's going to be okay. So we want to check that our window satisfies a condition. So that's going to be what's our condition? That means our window is big enough. So if, and remember, for a sliding window, to check the window size is going to be right minus left plus 1 pretty much always. That's the current window size you have, is equal to window size. Then we are going to, we need one more thing here that I forgot, so we need a result array. And then, like I said in the picture, we're just going to make every single element equal to -1, and then we'll just change the values that we need to, and then everything else will be -1. So this is going to be length nums. It needs to be the same length as our input array. Okay, so if this is true, that means we do have a valid value that we need to be put in. Now, where do we put in the value? Well, like I said, it's going to be res left plus k is the value, and you can see from this picture as well, right? So you want to put it at index 3, so the left would be 0, so it would be left plus 3, which would be 3, which is exactly where it needs to go. Now we do, so what value are we putting in? Well, it's pretty straightforward as well. We need to get the average. So in Python, you can do this double divide, which is an integer divide. So it will get rid of the decimal for you. You will have an issue here with negative numbers because this rounds kind of weirdly. So if you have a number like 2.5, it'll round it down. But if you have a negative number like negative 1.5, it'll actually round it to the smallest possible number, which means it'll round it down to -2. So you could use like math.floor, I think, if you wanted to avoid that. But we're going to do it like this. So what we're going to want to actually do is, what's an average? Well, the average is the total over the window size, because the window size is how many elements we have. So the average is the total over number of elements. And now remember that if we did have a valid window size, we are guaranteed to be moving the left. And so this check actually is going to be in this if statement here. So if we do have a valid window size, we're guaranteed to be moving the left. As you can see for this picture, again, once they had a valid window size, you're guaranteed to be moving the left side of the window every time. because you need to maintain that window size. But until the window is big enough, you don't actually need to move the left. So to move the left, pretty straightforward. Remember, we're going to be subtracting the value in left, and we are going to be moving the left to the right. So we're going to just left plus 1, and then we can do a return result, and hopefully I didn't miss anything. Looks like I did. Okay, so it looks like we are doing something wrong in terms of calculating our window. So let's take a look. So we have left, we have window size, we have a result, total. So this is the index, this is the value, total plus equals value. If right minus left plus 1 equals window size, okay. Result, less plus k. Okay. Interesting. I think I actually want to print the right and the left, just to double check here where we're at. Let's see here. Okay, so 0, 6. So our window size here is actually 7. Yeah, so it should be these 3 windows. So that looks fine to me, right? 0, 6 is a window, 1, 7, 2, 8. So that's fine. Okay. So if right minus left plus 1 equals window size, let's actually just say print it or something, but it should be fine, I think. Oh, yeah. Okay. So this is a classic specialist at making that mistake. Okay, there we go. So that's all we had there. We just had an equals. There we go. Okay, perfect. All right. So that is it for that. And let's do the time and space complexity here. So for the time, it's going to be big O of n because we have a sliding window, so that's going to be a guaranteed big O of n solution. For the space, we do have the output array, but usually you don't count that as part of your output. And for a sliding window, we just have a left and a right pointer and a window size. We didn't actually allocate any more memory, so that's going to be big O1. Alright, so that's all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. It helps grow it a lot. Thanks for watching. Bye.